Hi guys, in this video I'll explain how to create a class diagram in PlantUML. I'll be using IntelliJ, but you can also do the same on the PlantUML website. You simply go to plantuml.com, and then if you scroll down, you can see the different diagrams that you can create. In this case, I'll be creating a class diagram. So here you can click on class diagram. They have a bunch of examples, and for each example, you can click the edit button on the side. This will take you to the editor. Here you can make changes, and then you will see the diagram at the bottom. In my case, I'll be using IntelliJ. If you want to install the IntelliJ button, please check out my other video. I put a link in the description below. In order to explain the PlantUML syntax, I'll be using a simple example which represents a JavaFX application that has a single window. It is a client-server application where a user can add items to a shopping cart and remove items to a shopping cart. Now, the first line here, I have an interface named item. You can see the interface drawn out over here. Then the next three lines, I define an inheritance relationship, which says that the class toy implements the interface item. And the same applies for tool and breed. So here you can see the three classes implement the item interface. And this is defined by the inheritance relationship, which looks here like an arrow pointing to the interface. And what PlantUML does, it just infers that everything is a class by default. For example, if I remove interface item, it will assume that item is a class as well. Now you can see I have class inheritance relationship here. Now, if I want an item to be an interface, I type in the keyword interface followed by the identifier, which is item. If I wanted toy to be an interface too, I simply would type in interface toy. Now, this would then draw out that the interface toy extends the interface item. Now, I revert this back. I can also make classes explicit. So I can type in class toy, for example. This will not change anything. It just makes the markup more complex. So it's a good habit to leave this out if you don't really need it. Next, I add a class that represents the shopping cart. I define this by the class keyword, the shopping cart name, and then curly braces. This is similar like in Java. Then I add a member variable, which is a list of items, item being the interface up here. I name this items, and then I have four methods: to add an item, to remove an item, to get an item, and to get the size of items in the shopping cart. While I make changes over here in the markup, for example, if I remove the size method, the diagram is continuously updated. So you can immediately see what the diagram looks like. If I add size back in, it also gets added over here in the diagram. This represents a class. In UML, the class name is always at the top. C stands for class, I stands for interface. Then you have member variables, which is the items over here. And then the third part of the class are the methods and constructors. Now I also want to add the access levels. By default, most of the member variables should be private. This can be done with a minus, and then you can add a plus for public methods. If you don't add anything, that would mean it's package private. Basically, you do not have a modifier in Java. You can also put the sharp, which means protected. In this case, I want to have all of these public, and that now represents the shopping cart. Next, I want to add a relationship between the shopping cart and the item interface. You can already see by the member variable that a shopping cart exists of 0 to n items. And I want to draw this out in UML. I will use an aggregation as the relationship. Sometimes you also see composition. Composition is typically used when a shopping cart has to have an item or multiple items to exist. In this case, it doesn't need any items to exist. It can just exist by itself. That's why I'm using aggregation. Now here I type in the shopping cart identifier, so shopping cart, then the symbol for aggregation, and then the interface item. Now you can see that the diagram is updated. Shopping cart at the top. The diamond means that it's aggregation, and then a shopping cart consists of 0 to n number of items. Sometimes you see that the member variable that represents the relationship is left out because it's already represented by the aggregation relationship. But I like to leave it in because I can also specify the data type of the collection that I'll be using. In this case, I'll be using a list of items. Now, if you want to do composition, you simply use the star or the asterisk instead of the O. Next, I want to add a class named client. So here I have a class named client that has two methods: to add an item and to remove an item. I also want to add the corresponding server class. I name this server. The server has a shopping cart that keeps track of the current shopping cart, and I can add items and remove items. So basically, whenever I call on add item on the client, this will make a service call to the server, and the server will update the shopping cart and then return the number of items in the shopping cart. As a next step, I want to add the relationship that a server updates the shopping cart. I do this with server and arrow to shopping cart. So here the server basically manipulates the shopping cart. It adds item to it and it removes items from it. I want to also add the relationship between the client and the server. So again, I draw a connection from client to server because the client is always the one that makes the calls to the server. And then the server updates the shopping cart. And I want to say that the client is composed of the shop view. And here you can see that shop view is basically inferred. I have no class definition, so it just assumes there is a class named shop view. And then I add an explicit definition of shop view. So shop view, it has two methods. It has the method load view and update. Update is always called when something happens on the view to update the shopping cart. The update gets the control elements on the shop view and then calls add item or remove item on the client. This will notify the server, and the server will update the shopping cart on the server. I hope this gives you an idea how to draw out diagrams in PlantUML. Thank you for watching.